Hello, good morning, dear students. Welcome to my second class on the pterophytes. So, I'm Dr. Vedavati Chaudhary from University of Science and Technology, Meghalaya. So, today we'll discuss regarding the morphological differences of the pterophytes. In the earlier class, the general account of the pterophytes we have discussed. So, today, what are the different groups of the pterophytes and what are the morphological differences that we will discuss. So see, when we talk about the morphological difference, morphology means the whatever characters we can see externally, the external characters. So there are different characters are there, but it would be better when we discuss this by comparing the different groups. So I am following a Reimark classification, which is also supported by Swanee. So here that in this group, very easy classifications I have taken, where all the classes will discuss one by one. The pterophytes we can be divided into the five groups: Coelophytopsida, Coelotopsida, Lycopsida, Sphenopsida, and the Pteropsida groups. So let us first discuss the Coelophytopsida group. So Coelophytopsida, this group, all the members, these are the fossil plants. They have a order Coelotales or Coelophyta. They developed during the upper Silurian and the Devonian period. There are mainly three genera are there: Rhynia, Horneophyton, and the Coelophyton. The general characters, if you see, they lack two roots or two leaves, but they have a vascular system within a branching cylindrical stem. The living slute is single member is living slute is the whisk part. So some members they keep them under the Coelophytopsida group, some members keep them under the Coelophytopsida group. So sometimes it is added to this class or sometimes added to that class. But this class should not be confused with the current use of the name Coelophytopsida, which refers to the class of living ferns containing only the coelotes. Only the whisk ferns are there, and the Ophioglossy movers or the adder's tongue fern. So let us discuss what the structure contains or what are the morphological speciality this group contains. So this group we can see one picture also, I think all of you can see. It is the fossil picture of the Rhynia major. So this group contains all the fossil plants which are not there. So whatever characters these are found from the fossil plants. So all the plants are extinct, and the sporophytic plant body, if you see, these are rootless. And the body is divisible in the prostate rhizome is there, and the erect portion is there, and the aerial branch, if you see, it is dichotomously branched. Already I have told you in the earlier class what do you mean by the dichotomous branching. Branching in the branches, no leaves, you can see either it is naked or it is covered up with very small spirally arranged appendages. So leaves you cannot see in them, but yes, they develop the cones or the strobilus. So on the rhizome, they bears the rhizoids, and their stele is their stele. It is very primitive type, only protostele. Protostelic type of the stele you can see in the all the primitive type of the pterophytes where there is no teeth is present. So the sporangia it is terminal, no sporophyll is there, so either it is developed in the solitary or it may develop in some groups. Sporangia, if you see, only the fossil records what it is found. The sporangium it is very thick walled, and inside this it bears the spores, but all the spores are same type, homospores. And spores are arranged in the tetrad fashion. Tetrad means suppose tetra four, no, one, two, three, and suppose on the front sides and the back side, the fourth one. So in the triradiate ridge, it is present. For tetrad like fashion, it is present. So what characters? So here all the primitive characters we have seen. Let's come to the second group. It is the Coelurotopsida group. In Coelurotopsida group, it has a single order, Coelotates, and only two families are there, Coelotaceae and the massive Pteridaceae, and where each family has single genus, Coelurota or the massive Pteris. I think you can see one picture is there. It is the picture of this fern. So which fern, if you see what the plant part it contains a rhizome. A aerial stem is there. It is a mature sporophytic plant. Some scale-like outgrowth you can see, and there suppose in the main stem you can see some node and internodal region is there, and from the nodal region it develops the small sporangium. Sporangium also, if you see the how it looks like, it is a triradiate type of the sporangium it forms, and in each sporangium it forms develops the spore mother cells, where these spore mother cells, when they go for the meiosis, they develop the haploid spores. After that, the the morphological characters, if you see in them, characters are similar to the primitive group or the Coelophytopsida group. That means they also do not have roots, they bear the rhizoids, leaves are not present there, appendages may be there, and very simple dichotomous branching you can see. And the gametophytes, these are colorless, cylindrical, branch, subterranean, saprophytic in nutrition. And the antheridia, it is partially embedded and it is partially projected on the gametophyte. Antherozoids are the multiflagellate. Next group, if we see, it is a very big group. Lycopsida group. Lycopsida group is developed during the Paleozoic era. And because it contains 5 living genera, Lycopodia, Phyloglossum, Isoetes, Stylites, the Scylla genera. So here both living member you can see and the fossil members also you can see. So what the general body you can see? See, the main plant body is a sporophytic plant body, and the body is differentiated into root, stems and the leaves. Leaves are very small, so this microphyls. In the center it develops a single plant. And leaves, the arrangement, if you see in the Lycopodium also, it is spirally arranged. It is arranged in a whole scoring opposite. All the leaves of the Selaginellite is ligulate. Ligulate means in the in the lower portions or in the base portions of the leaves, a small outgrowth is found, which is known as the ligules. Which is known as the ligules. Then stelees may be protostelic, siphonostelic, polystelic. So protostelic you can see in the all the primitive groups, you can see the protostelic. Then in the much more advanced type you can see the siphonostelic. So what is the characters of the siphonostelic is that in the siphonostelic you can see the pith, whereas no pith is present in the protostelic. Then polystelic. Polystelic, it is suppose in the main, if you cut the stem, there you can see some branches, small groups of the stele you can see. Leaf gaps are absent. Then sporangia develop in the adaxial surface of the opposites at the terminal portions of the branches. That means at the apex portions or the tip portions of the branches, it bears the sporophylls. Sporophylls bear sporangium are known, and the sporophylls are arranged the strobilus. So sporangia, it may be homosporous. For example, in Lycopodium, you can see the homosporous type, and it may be heterosporous. For example, in Selaginella, it is all the spores, these are the heterosporous. And antherozoids may be bi or it may be multi-flagellate. I can show you some pictures. See, this is the pictures of the Lycopodium. Different member. You can see the leaves. See, very small. And what is the arrangement of the leaves? So here it is arranged in some holes. The Lycopodium, different members, different species of the Lycopodium are available. And it is the picture of the Phyloglossum. Little bit it looks like fleshy types of leaves are there. Then isoetes is a very typical one. If you see externally, it looks little bit like the onion plants. But if you see the main one, in the isoetes, three different types of the leaves you can see. There is an outer hole of leaves which are known as the megasporophyll, middle hole, microsporophyll, central hole of the leaves. This contains the sterile sporophylls. Means whatever sporangium is present, is at the sterile. So in these three holes, the isoetes is present and it is also heterosporous. Next, yes, this is the Silaginella. Silaginella, as I have told that Silaginella, the stem it contains two different types of leaves. Little bit of small microphyls and little bit of larger megaphyls are present in the same plant. And here one single leaf you can see. See, there is a midrib is there, a small ligule is there. They are outgrowth type. You can see the black one, it is the ligule, and also the glossopodium in the lower portions. Glossopodium actually it is the structure which stores the starch or the food material. It is present. Then comes the Sphenopsida. It is represented by one living member, Equisetum, and 18 fossil members. So only the living member single one is there, that is called as the Equisetum. So Equisetum in the main plant body, if you see, that is also divisible into root, stem, leaves, and the stem is articulated. Main stem, if you see, is some small ridges you can see in the plant, and longitudinal furrows you can see it is well branched. And the branching, if you see, two types are there: the sterile branches and the fertile branches. And the stem it is ribbed and divisible into node, distinct node and internodes are there. All the branching the stems it is found in the case of the sterile one, but in the fertile branches no branching is there. Leaves are very small, scaly, they are arranged in the node and in the form of the hole. Stems have solid or the medullated proboscis. And the secondary thickenings are found if you touch the Sphenopsida stem, very hard type. And there the spores they produce mostly homosporous, but the fossil groups these are heterosporous was there. In the sporangium it is very much thick walled. The spores develop in prothallus, monoecious or dioecious, and the antherozoids are the multiflagellate. Antherozoids are the main sperm. These are multiflagellate, and embryo are without any suspensor. See, it is the equisetium. Here, whereas these stems in the center, it contains both sterile and the fertile branches. After that, it is the after the Sphenopsida group is the Pteropsida. In the Pteropsida, you can see include the ferns and also some fossil plants. So the members of these groups are commonly known as the ferns. It is a very big group and much more advanced type. So the sporophytic plant body you can differentiate it into root, stem, and the leaves are also spirally arranged. So in Ophioglossums, the plant body it is unspecialized, but in Filicus it is very much complex. And they are mostly epiphytic. Ophioglossum and the few others are the aquatic. See here the pictures you can see the Marsilia is there, then it is the Salvinia is there, then Azolla is there. These are all aquatic pteridophytes. So they are the most advanced type, and some of the members are very very small, but some members, ferns, suppose cyclones, they are very large. Some are creeping, and the leaves are mainly large size, so these are megaphilous leaves called as the fronds. They are generally differentiated into a petiole and a dissected leaflet and a ridges. The leaflet has a prominent leaflet, suppose pedicles. The leaves of pedicles are the axstipulate, no stipules are there, while in some groups stipules are there. Some plants, suppose Asplenium, Bryopteris, the antlers, the leaf base are found, modified leaf base are found known as the tropopod. Tropopod actually means for the starch storing organ. So stele it is different types. Maybe a simple protostele also found in the primitive one, but complex siphonostele, then solenostele, dictyostele, polystele. These are the when we discuss the different types of the stele, what are the found in the pterophytes. I can explain this you very clearly. But what are the different types of the stele is available? What are the special characters of different types of stele? Only know that now. Protostele, these are the stele where there is no peat is there, but the siphonostele you get the peat. Then soleno, dictyo, polystele, these are also the different types of the stele found in the farm species. These are the modified ones. Tracheary elements of many species of ferns are the scalariform, transage opposite, transage alternate, short slits, simple ovate. And each leaf it bears numerous sporangia, either the margin or the surface of the leaf blade. Generally, they are homosporous, but few are the heterosporous. So, after the germination, spores develop a heart-shaped thalloid or the small green gametophytic structures. The gametophyte may be endosporic or it may be exosporic. So, these are the different morphological characters that we can see in case of the pterophytes, where from the primitive, again if we brush what we have learned, then within these five groups, suppose the Coelophytopsida, Cetopsida, Lycopsida, Sphenopsida and the Pteropsida, what the differences we have found, that in the Coelopsida, all the groups, these are actually these are fossils, but where the main plant body no leaves you can see no leaves are there. Only you can see the dichotomous branching, very simple type of the stele is there, protostelic type, and the sporangium also it is very thick wall sporangium it is there, and the spores are all the homosporous type. The sporangium development it is eusporangiate type, and they don't develop any roots, they rather they develop the rhizoids. But when it crosses further, for example, the Lycopsida, then the Sphenopsida, then Pteropsida, these groups, you can see that some members are homosporous, some members are heterosporous also there. And the different types, the leaves also you can see. Suppose in the Selaginella, the micro and the mega, those different types of the leaves you can see, but in the ferns, mainly they produces the large kind of leaves which are known as the fronds. So these are the different morphological characters of the pterophyte, and I hope that it will help you to know the, the morphological characters better. And later in the class, that next class, we will discuss all the anatomical characters or anatomical differences of the